What if I told you a robot can now see your world, predict your next move, and correct its own mistakes before you even blink? Boston Dynamics just plugged a mind-blowing perception system into Atlas. And trust me, this flips the entire robotics game on its head. Welcome back, guys. You're watching Next Gen AI. For decades, robots have been laser-precise in labs, yet painfully clueless in the messy real world. Factories, warehouses, even your living room throw constant curveballs. Shiny parts, bad lighting, humans strolling past. One tiny surprise and the bot freezes like Windows 95. Picture a supposedly simple task. Pick up a car part and slide it into a shelf. Child's play for us. A headache symphony for machines. First, Atlas must spot the right object in a sea of metallic glare. Next, locate its exact pose. Open air or tucked deep in a bin. Then comes the grab. Reach with millimeter precision. Clamp the 3-finger gripper. Feel the weight. While carrying, the robot replans its path 30 times a second to dodge obstacles. Finally, placement. Miss the slot by 2 centimeters and the part jams or tumbles. That kaleidoscope of micro-decisions is why earlier robots stalled whenever anything shifted. Until now. But here's where it gets crazy. Atlas isn't just spotting things. It's interpreting and adapting in real time. The way you instinctively sidestep a coffee spill without thinking. Its first new superpower is a lightning-fast 2-dimensional object detector running entirely on board. No bulky server farm. Twin stereo cameras feed a lightweight neural net humming along at 60 frames per second. Shelves pop up outlined with green corner dots, every cubby peppered with red key points. Those dots aren't decoration. They define the geometry Atlas needs for safe motion and perfect alignment, spotting fixtures, car parts, and stray tools in under 40 milliseconds flat. But here's the insane part you didn't expect. Seeing in 2D is child's play, understanding in 3D is the real trick. Atlas fuses those dots with an internal CAD model using an algorithm called fixture localization, so the robot knows a shelf's pose in space down to a few millimeters, even if half the markers vanish from view. Enter Super Tracker. Imagine combining your eyesight with the proprioception in your elbow. Atlas merges camera data with joint angle sensors every 20 milliseconds. During a live test, an engineer actually slid the shelf 2 feet sideways while Atlas was mid-task. Instead of panicking, the robot paused for a mere blink, snapped to the shelf's new coordinates, updated its plan, and still nailed the placement. If the part slips, Super Tracker senses the mismatch between predicted and actual force, triggers a recovery routine. Grab, realign, retry. This hybrid vision kinematics loop gives Atlas a sixth sense. It can track a held object even when the cameras can't see it, just like you know a mug is still in your hand behind your back. And it doesn't stop there. Atlas just mastered a skill humans spend years perfecting: surgical hand-eye coordination. Boston Dynamics runs painstaking calibration routines, overlaying Atlas's internal 3D skeleton on live camera imagery until virtual and real arms align pixel perfect. Temperature drift, bumper dings, even a loosened screw can nudge sensors off by a hair. Engineers recalibrate so the math matches reality. The payoff? ±1 millimeter placement accuracy. Picture threading a needle with an 8-kilogram steel part every single time. That precision upgrades Atlas from flashy demo bot to bona fide industrial coworker. So what happens when chaos meets precision? Roll the lab footage. Atlas scans the rack, sidesteps to a line, locks onto the part, grips, and walks. Mid-stride, an engineer accidentally bumps the shelf. The robot hesitates for an eye blink, recalculates with Super Tracker, and reroutes. No operator intervention, no scripted restart. Drop the part? Wide-angle cameras spotted on the floor. Torque sensors confirm the weight vanished. The planner spawns a recovery trajectory, bends down, regrasps, and continues. It's the robotic equivalent of a barista rescuing a falling cup. Messy for a second, then business as usual. Boston Dynamics calls this fusion of sensing and motion athletic intelligence. Think of an Olympic sprinter. Eyes scanning hurdles, legs reacting before the brain can say jump. Atlas is chasing that same fluidity. The roadmap points to a foundation model, one giant neural brain unifying sight, balance, and manipulation, so the robot can learn new tasks by demonstration, not recoding. Fast forward a few years, an Atlas stacks boxes all morning, then someone hands it a toolkit. Instead of freezing, it visually inspects the wrench, loads the CAD file, and within minutes helps tighten bolts on the production line. No overnight retraining. That's the quantum leap. So here's the polarizing question. If Atlas can already self-correct and work unsupervised, how long before robots edge humans off the factory floor? Sound off in the comments, and hit subscribe for weekly deep dives into the frontier of AI robotics. Until next time, you've been watching Next Gen AI. Stay curious and stay ahead.